Hey there, science fans! Today we're diving deep into the fascinating world of crude oil refining, specifically a process called atmospheric distillation. This process is like a magic trick, transforming gooey crude oil into the fuels and products we use every day. Imagine a chef separating egg yolks from whites. That's what atmospheric distillation does with crude oil. It's the first and most important step in turning this raw material into something useful. Get ready to discover the secrets of this amazing process. We'll explore what crude oil is, why we refine it, and how atmospheric distillation works its magic. So, buckle up, and let's embark on this exciting journey into the heart of oil refining. Crude oil is a thick black liquid found deep underground. It's a mixture of hydrocarbons, which are molecules made of hydrogen and carbon atoms. Think of crude oil as unbaked cake batter. It has all the ingredients but needs processing to be useful. That's where refining comes in. Refining transforms crude oil into usable products like gasoline, diesel, jet fuel, and even asphalt for our roads. Without refining, crude oil would be as useful as a chocolate teapot. Refining separates the different hydrocarbons in crude oil based on their boiling points. It's like sorting Lego bricks by size. Each size has a different purpose, so refining is essential for unlocking the hidden potential of crude oil and providing us with the energy and materials that power our world. Refining crude oil involves two main steps: primary and secondary separation. Primary separation is like using a strainer to separate big chunks from smaller ones. It removes water, salt, and solid impurities from the crude oil. Secondary separation is where the real magic happens, using a process called atmospheric distillation. This process separates the remaining crude oil into different fractions based on their boiling points. Think of it like baking a cake. The oven's heat causes different ingredients to bake at different rates. Similarly, atmospheric distillation uses heat to separate the different components of crude oil. Each fraction has a different boiling point range, resulting in products with various uses. It's like separating a rainbow into its different colors. Now let's break down atmospheric distillation into 3 easy steps: heating, separation, and condensation. Step 1. Heating, and a little desalting. Before the real fun begins, the crude oil gets a spa treatment. It's mixed with water to remove salt and impurities, preventing corrosion in the distillation tower. This desalting process is crucial for a smooth operation. Next, the desalted crude oil enters a furnace and gets heated to a scorching 350 to 400 degrees Celsius, or 662 to 752 degrees Fahrenheit. This high temperature vaporizes most of the hydrocarbons, turning them into a hot gas. Step 2. Separation is key. The hot vaporized oil enters the bottom of a tall distillation tower. This tower has trays at different heights, each with a specific temperature. As the vapor rises through the tower, it cools down. The different hydrocarbons condense back into liquids at different heights depending on their boiling points. Lighter hydrocarbons with lower boiling points, like gasoline components, condense near the top. Heavier hydrocarbons, like diesel and jet fuel, condense lower down. Step 3. Condensation, back to liquid form. Once the hydrocarbons condense on the trays, they're collected and piped away. These collected liquids are called fractions. The lightest fraction, containing gasoline components, collects at the very top. Heavier fractions like kerosene, diesel, and lubricating oil are collected at progressively lower levels. The heaviest fractions, like asphalt, remain as residue at the bottom. It's like a liquid layer cake. Atmospheric distillation is the workhorse of oil refining. It's a vital process that provides us with the fuels and materials we need for transportation, energy, and countless other applications. However, atmospheric distillation has limitations. It can only separate a portion of the crude oil into usable products. The remaining heavier fractions require further processing. Despite its limitations, atmospheric distillation remains a critical process, laying the foundation for more advanced refining techniques. It's a testament to human ingenuity in harnessing the power of crude oil for the betterment of our world.